Hello and welcome to my video for week 8 of the Coursera course, Introduction to Interactive Programming with Python. This week we're working on Rice Rocks, our kind of asteroid-like game. And here it is, almost the end of the course already. So you're probably expecting some pretty advanced material in my video this week, right? Wrong, quite the opposite. Let's stay with the basics, my friend. I think they will serve us well. We're going to visit the discussion forum, and we're going to talk about function definitions and calls, which I talked about back in week 3, but we're going to revisit that. We're going to talk about method calls, which are kind of like function calls, but they use dot notation. So if you don't know what that is, that's fine. That's what we're going to talk about. But like I said, there will be quite a bit of review too. So stay with me. I'm going to go through some of the review quickly. I'm going to visit the discussion forums, kind of like Dear Abby. I don't understand the directions to Rice Rocks. Please help me. Well, that's a problem. If the directions don't make sense, it's kind of hard to do the assignment. Anonymous writes, this is actually from the discussion forum. Anonymous writes, totally lost on the following statements. The statements, of course, are taken from our development process for this week. Number 3, create a helper function process sprite group. This function should take a set and a canvas and call the update and draw methods for each sprite in the group. 4, call the process sprite group function on rock group and the draw handler. Anonymous writes, not sure what to do here. I have create the rock spawn function, which loads a global set rock group with 12 rocks. Not sure how to proceed to the next step. Please help. So what's going on here? By the way, did I mention that this video is part of my series of videos for people who are new to programming? If you're new to programming and you haven't been around people who talk this way, step 3 and step 4 might be kind of hard to understand. Maybe our anonymous writer did not watch my week 3 video and does not know what a function call is. A function call is when your program says, go to the function, like my function turn on oven, find the function and do it. When you define the function, it doesn't do the function, but the function call says go do it. And a function call looks like one of these. It might be the name of the function with parentheses. It might be the name of the function with parentheses with some parameters in between. Or it might even be a variable like oven state equals, and then the name of the, this part here is actually the call, the name of the function with the parentheses and any required parameters. If you do it this third way, with oven state equals a variable in front of it and equals, then oven state is going to be assigned the return from the function. So suppose turn oven on returns a Boolean, true or false. Then oven state, after this statement, will have the Boolean value that was returned by turn oven on. Whoops, oh no, my slide changed, there we go. If turn oven on returns a number, then oven state after this statement would have that number assigned to it. And if turn oven on has no return in it, oven state would have the value of none, because it's been assigned the return value of turn oven on. Okay, moving on. Now maybe Anonymous had some difficulty understanding those directions because perhaps this part, the function should take a set and a canvas, hasn't actually been explained to us. And so maybe that's why Anonymous is lost. So let me explain. A function takes the parameters or arguments that are passed to it. Huh? Well, a function definition includes the parameters that the function requires, and a function definition statement starts out something like define turn oven on with the parameters that are required, temp, time, and oven num, or it could have define turn oven on with no parameters required. Parameters are passed into a function, or they're passed to a function, or they could be taken by a function. This is sort of a language thing. Here are some ways that people refer to arguments. They refer to arguments, parameters, a parameter list, an argument list. You could say, let's pass x into the function. You might say, just pass in the height and width. You can pass that to function y, and it returns z. The parameters to pass in are listed in the user guide on page 3. These are all ways people talk about these arguments and variables and things that get sent on over to your function. You could say set timer takes start time in minutes and returns a Boolean. You should give that function rock group. It will update each rock and return the number of collisions. These are ways that people talk about the parameters passed to a function. So now can we understand step 3? Maybe a little better. It says create a helper function process sprite group. This function should take a set and a canvas and call the update and draw methods for each sprite in the group. Let's break it down. Make a function named process sprite group. So that's going to look like define process sprite group. Pass in a set and a canvas. That says put those over there in the parentheses. And then it says call the update and draw methods for each sprite in the group. So in the function, that's going to look something like for each sprite in the group, call the update method for this sprite, call the draw method for this sprite. That's pretty good pseudocode. They told us a lot there in step number 3. What about step number 4? 4 says call the process sprite group function on rock group in the draw handler. Let's see if we can break that down. Make a call to the function named process sprite group. Well, that'll look like this. Whoops, no, it'll look like this. We need some parameters. I remember there was rock group and canvas that were the parameters for this function. For this function. Put the call in the draw handler. It said call the process sprite group function on rock group. Okay, so we're calling it with rock group in the parameters. That's what that says. And then in the draw handler. So if we put it in the draw handler, it'll look something like this. It'll be in the draw function. And where we used to have a rock draw canvas, now we'll have process sprite group, parenthesis, rock group, comma, canvas. Okay, we're doing pretty good there on step 4 too. Well, a helpful peer of ours wrote into the forum and said, you need to pass the name of your rock group as an argument to the process sprite group function, because it has the parenthesis, the process sprite group function. You can then do the same with missiles and explosions so that you only need to write one piece of code to process each of them. Sounds like some good advice. Anonymous writes back, I've been trying to pass my rock group to process sprite group, but after trying many different ways, the rocks either don't update or don't get drawn at all. I'm confused and frustrated. Please help. Well, Anonymous, I'm trying to help. So what about definitions and calls for methods? Now we're using object-oriented programming. And besides having functions, we have methods too. And here's where it gets a bit more complex. Method definitions list self as a parameter, but method calls do not list self. So a function definition and call, reviewing with going back to functions, a definition and call will match the parameters in order. So it looks something like this. We have the definition of this function, and then we have a call to this function. And what's in the first position here will match up with the first variable here, and so forth. The second to the second, the third to the third, and the fourth to the fourth. We know that whatever's in the parenthesis will match by position, 1-to-1, to what's in the parenthesis here. Well, when we get to methods, which are functions that go to a class, it doesn't work that way. We have to put the object that we're using as self before the method name, like this. My house is an object that's going to represent self for the duration of this call. And then we skip self in the parameter list here and match the remaining parameters in order. So what I mean by that is, if we were looking at this definition statement, and we said, well, there's 1, 2, 3, 4, 5. There are 5 items in it. And then we tried to match these items, there'd only be 4. 1, 2, 3, 4. But that's the right number because we have to skip self, because self moved to the front of the list and has a dot after it. So there really are 5, but the first one's here. So it's 1, 2, 3, 4, 5. Well, it depends on how you count, I guess. That's why it's a little confusing. This business is called dot notation. I even looked it up in Wikipedia. It's a new term I learned last week. Dot notation is used in calls to methods. The format of dot notation is you list the specific object, then a dot, then the name of the method with parenthesis, and any other arguments that are required, of course, go in the parenthesis. The example would be my ship dot turn right, where my ship is a specific object and of a class, of course, that turn right goes to. And then there's a dot, and then there's turn right, which is going to be a method that is defined in the same class as my ship is defined. A lot to think about. But anyway, dot notation does make things a little more complicated for us in looking at the parameter lists for our calls. Another peer writes to the forum and says, but I still don't understand where I went wrong with player hand add card, parenthesis new deck dot deal card. Whew! Some methods seem not to require the parenthesis, while some do. Well, actually, methods and functions are defined with parentheses like this. Methods and functions always have parentheses. When you use the method, you always use parentheses like this. Variables do not have parentheses, so my ship does not have parentheses after it. If you try to use a function or a method and you forget the parentheses, it won't work. It thinks you're using a variable. If you have a variable with parentheses after it, it's going to look for a function or a method. That won't work either. It thinks you're trying to call a function if you have parentheses like this. And the part that's most confusing is, of course, dot notation, where we have my ship dot method. This needs parentheses because it's a call to a method, but the variable name is in the beginning, so it's a variable name and a method. It might sort of seem like it's breaking the rules because if you look at the my ship part, it's a variable, and if you look at the method part, it's a function. But overall, it's a call to a function. It simply has the object being operated on in the front using dot notation instead of having the object that you're calling the method for in the parentheses. So this is still a method call, even though it begins with a variable. It could seem like it breaks this rule here that says variables do not have parentheses, but it's because this is a function call, or actually a method call, that the parentheses are needed. I hope that that makes sense. It can seem pretty confusing, but it's important to understand these basics so that you can know what you're looking at in your programs and also when other people are talking about programs. Well, that's my material for this week. Like I say, there was some review, but I think these things are important to understand. Since this is the end of the class, I'd like to thank our teachers, teaching assistants, and Coursera for a great course. What will I do without the discussion forums? I don't know. I've really been spending a lot of time in there. Reading the forum took me back to learning programming for the first time. Programming involves learning a different way to think, and there's a lot to learn, especially in the beginning. That led me to making videos. I've never made videos before. Hats off to the newbies who made it through this. You were learning Python and programming and debugging and a whole bunch of new stuff all at once. I hope my videos were good company for you on the adventure. Thanks for watching. See you around.